Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
Welcome to the Web Platform Podcast, episode number 156, where we are very excited to be talking about React 16, which includes Fiber, the Context API, and just other cool things going on in React world. With me, as always, is Amal Hussein.
Hi, everyone.
And it's just me. So it's just got two of us this week, but I'm sure that's going to be plenty of time as we have plenty of people as we have a ton of stuff that we need to cover. But before I introduce our very special guest, I'm going to kick it over to Leon, who is going to tell you about This Week in Web in 2 minutes or less.
Thank you very much, Danny. So first of all, we've got Webpack 4, which has now been released, and it includes loads of new stuff and also has a 98% performance increase. Chrome 65 has just been released, which includes various security fixes and improvements, which includes the new CSS Paint API, which allows you to programmatically generate images. That looks very cool indeed. Debugging memory leaks in Chrome just became a lot easier. So in Chrome 66, the DevTools can now trace and snapshot C++ DOM objects and display all reachable DOM objects from JavaScript with their references. The front-end development tooling survey is back, so take part now to help gain insight into what tooling developers are using today. So there's still tickets available for the Perf Matters conference happening later this month in Redwood City, California. So if performance matters to you and you're in the area, grab tickets while you still can. Version 5.2.0 of NGRX, the reactive extension for Angular, has just been released, which includes plenty of fixes and features. And that's everything for me for This Week in Web. Before I hand it over to Danny, I've got the pleasure of announcing the winners of our Google Daydream View headset giveaway. I'd like to thank everybody who's taken the time to actually sign up and subscribe to our newsletter. We've had a great response, much more than we thought we would do. But out of the people that have subscribed during February, we've chosen two lucky winners. The first one is Danny Callahan from the UK and Brian Voss from the United States. Congratulations to both of you. We'll get those sent out to you as soon as possible.
Thank you, Leon. It's good to see that the web has not stagnated in the last 2 weeks since we recorded. Excellent to hear. So, like I said before, we are going to be talking all about React and we're going to talk a little bit about what it is, but we're mostly interested in React things that were in React 16, so React Fiber and some of the newer things that have been announced. So, with us to talk about that is our very special guest, Andrew Clark.
Hello.
Andrew, thank you very much for taking time out of your busy schedule to come chat with us and teach us a bunch of things about React. So for those that may not know you, give everybody a brief introduction. Tell us who you are, what you do, and what you like.
Okay, yeah, thanks for having me. I'm really excited to be here. So my name is Andrew Clark. I work on the React core team at Facebook. I've been there for about 15-ish months. Oh, no, I guess more like a year and a half. So I came from the open source world. A lot of people on our team, it's about, 7 people. We came from as open source kind of contributors to the ecosystem. And now I work on React full time. Which is really great because I like React a lot. It's really cool. Before that, I was building apps with React at a company called OpenGov. We were building software for like local city and municipal governments. I was working on like a budgeting tool using a lot of the frameworks and infrastructure that I now get to work very closely with at Facebook. So React, GraphQL. We used Relay at OpenGov as well. We used Flow a bit. And then before that, I was making like WordPress websites and like marketing sites for this little design shop in Gainesville, Florida called Paris Leaf. And that's kind of where I got my start. But open source is really how I was able to eventually somehow trick Facebook into hiring me and land kind of my dream job right now, working with a lot of smart people at Facebook on React.
That's super cool. And so do you now work on React full-time via Facebook?
Yes, yeah, that is my full-time job. I'm on the React core team. So we have a few React teams at Facebook. A lot of people have this conception that there's like, I know Dan, one of my teammates, Dan, has mentioned that like when he was first using React, he had this idea that there's a whole floor of people or a whole like building of people at Facebook working on React, because it just seemed like that. Oh, that must be how it is. But we have a few teams. It's not a whole floor. We have the React core team. It's 7 people, including me. And then we have a React native team, which is, I can't remember the exact number of people, but about the same size, maybe a little bit bigger. And they work on all React native and related stuff. They also work really heavily, as does the core team, but we also work with product teams at Facebook to help them with any integration problems or any problems they might have with the framework. And that also informs a lot of the work that we do and eventually open source. And then there's this like a React data team that does, it's kind of similar to the React native team, where they don't work on the core of React itself, but they work on kind of integrating with the product teams at Facebook. And again, that informs a lot of the stuff that we do.
Yeah, that's pretty cool. And I've often heard that there's like an internal version of React and an external version of React, or something along those lines, where there's like things being maintained closed source. Is that accurate?
So we are GitHub first. React Native is a little bit more like that, but we do all of our work on GitHub first, and then we sync back to our like internal repo at Facebook. So every week ish, we have like an on-call who's assigned. But every week ish, what we'll do is we'll take whatever's on GitHub master, which is like the source of truth, and we will sync it back to our internal repo. So Facebook.com and Messenger.com, those are always running like some version of React that's not public yet. And the way I like to pitch this is it's not about exclusivity really, although that's part of it. It's more about like, we don't want to ship things until we've proven that they actually work in production. So you can think of it as Facebook is like the guinea pig for all of our open source people. Like, we're not going to inflict our bugs and our flaws on you until we have inflicted them on, I guess, all of our users. But that's the basic flows. We land something on in the form of a PR, we merge it into GitHub into the master branch. Every week or so, depending on how risky the change is, we will ship it to Facebook. Inevitably, we find some little edge case we did not consider, either via like a unit test or there's some bug that was reported. We fix it and we merge it back into React. And then for like our open source releases, we're a little bit more deliberate about making sure those are super stable before we just give them to everyone. So for instance, we recently did like a full rewrite of React. React DOM was mostly the same, but like of the core framework, it was just a total ground up rewrite. And that would have been it was kind of a risky change to make, but it was super stable. React 16 was their first release where we gave this to everyone. And because there were no API changes, it was an incredibly smooth release. We had already kind of ironed out all of the bugs months before via our internal testing. So the strategy has actually worked out really well for us.
Oh, that's pretty neat. I've always told people that like Facebook is one of the most exciting places I think to work as a web developer, purely because, there's the ratio of like impact, like how many developers are working at Facebook and how many people actually interact with the, HTML, JavaScript, and CSS that, Facebook has is insane. And secondly, I think maybe it has some of the largest web and mobile products, without having a browser, so it's kind of like in that sense, it's also like a very unique company. And so getting back to React, we don't want to make any assumptions for our listeners. Can you tell us just in your own words what React is, and also what problems React was initially trying to solve? I know that you're sort of, you're newer on the team. Maybe you haven't been there since the inception, but I'm sure you can hopefully answer that.
Yeah, so React, in as few words as possible, is a library for creating user interfaces in JavaScript. So if you've heard of other frameworks like Angular or Ember or Backbone, it's very much in the same, or Vue, I guess I should say now. It's very much in the same vein as those libraries. It's like if you want to build a highly interactive, immersive web application, whether it's or a single page application or maybe just integrating some small into a larger application that's not like a single page, but you just want to add some interactivity, you would use React for something like that. It was originally designed in our ads organization at Facebook. It's one of our tools, or one of our products that's like kind of pretty important to Facebook. That's how we make all of our money. And it was designed in that org as a way to just deal with the problem of developer complexity, where front-end web development and app development can be really tricky, especially if you think back to like 7-8 years ago. There's a lot of complexities involved in building web applications that are nice to use, that are provide a good user experience, but also aren't a nightmare to maintain over time. If anyone who's listening who has built a web app before, you know that like code that you write today and tomorrow might look fine, but 6 months from now it could be totally inscrutable to the next person who has to take over your code base. So that was the original problem. The kind of innovation, for lack of a better word, that React introduced to the web application framework space was this idea that rather than having to think about how to update your app from A to B or B to C and issue these imperative commands to the DOM the way you'd maybe do with something like jQuery back in the day, React has this conceptual model where you just re-render the whole component every time that there's a state change. So it kind of ushered in this new era of thinking about your web applications as a projection of data onto UI, or as conference speakers like to say it a lot, it's React applications are like a function of data to a view. So that was kind of the core idea. There were some controversial parts of that in the beginning. One of the things that it was very well known for, especially in the beginning, was this idea of a virtual DOM, which is the idea that we don't make our changes directly to the DOM. First, we have this intermediate representation that we keep in memory, and then we diff our trees to create like some minimal set of mutations that we want to make to the underlying platform, which on the web is the DOM. And that was kind of how a lot of the marketing in the beginning, that's what it centered around. I don't think that's a super important part of it, but one nice aspect of this virtual DOM idea is that we can take the React concept and the React framework and apply it to other rendering targets. So we also have React Native, which is same exact framework, but used to build iOS and Android apps, and it's even being used at Oculus for a project called React VR. So you can build VR applications using React. So if anyone out there has used React, you are a VR developer now. It's official. And so that's also a pretty exciting project. So hopefully that's a good summary or overview for people who haven't heard of React.
Yeah, that sounds awesome. I'd actually forgotten about React VR, because I remember being very surprised about that, because I think it was I think John Carmack even mentioned something about it where he was like, oh, this actually ends up being a really good way to do this, which is not something I thought I would ever hear John Carmack say about JavaScript.
I was at a React Boston conference early last year, and there was an IoT, there was a drone being flown with React and Johnny 5, so I mean, like I'm waiting for like NASA to tell us like, oh, and we use React, and our GUIs in the spaceship are using React. Like, I mean, React is everywhere. It's insane.
Yeah. I mean, I think that's why, when I was introducing a few minutes ago, I said it was a UI framework first, and then I mentioned it was in JavaScript, and that's kind of how I think about it. Like, it happens to be written in JavaScript because that's what it's primarily a web framework, even though we do have React Native. So it was originally made for the web, and JavaScript is the language of the web. So it is written in JavaScript, but it doesn't necessarily have to be. Like, all of the things that make React really special, I shouldn't say all of the things, but a lot of the things that make React really special don't have anything to do with JavaScript specifically. It just, that happens to be the language that is most accessible for the people who we are building React for. But there's also React bindings for like Reason. People have taken the React concept and ported it to other environments. So like Facebook has a project called Component Kit and another project called Litho, which are essentially React clones, but for Objective-C and what is Android and Java? Objective-C and Java, respectively. The idea that React can be portable to all these different environments is one of the things that makes me really excited to be working on it.
Great. So, right before we get into where we really want to go, where we want to be talking about like React 16 and a bunch of the cool stuff, because you already mentioned the ground up rewrite part, and we want to talk about that a little bit. But React has come a long way since the early days, since the 0.x days. Are there any particular highlights kind of on that historical timeline that make that you just find particularly interesting? I mean, you even think about like when other projects related to it, like when React DOM became its own thing, React Native, even some of the testing stuff that came around it. Is there anything interesting up until React 16 that you find particularly interesting?
Yeah, so you mentioned the big one, which in my mind, which was React Native. I already knew, so I was very new to web development before I used React. I always say like, I don't really know that much about. I sometimes am embarrassed by my dearth of knowledge about like web development that is outside of React, just because I kind of, my first web development experience really was working on a React app. But I remember there are two things that were like really big aha moments that made me excited about React in the very beginning. One was this idea that you could render on the server. I thought that was so cool, because I always thought up to that point that it was a choice. Either you can have a client-driven app that you build with some sort of JavaScript framework, and it's very good for like highly interactive apps, but maybe the initial load time would be sacrificed because you have to load all this JavaScript. Then the other option was you have a classic server-driven app where you render everything on the server, and then you have to piece together things on the client if you want to make them interactive. But the idea that React could render, because of this virtual DOM idea, the idea that React could render on the server and then the exact same app could be used on the client was like a kind of a mind-blowing thing to me at the time. And then the second version of that was React Native, where I'm like, oh my goodness, it's not just the server, and it's not just the server and the client. It's also, I can render these React components on basically any platform once someone builds a render for it. So I think React Native was a huge thing, and I still think it's a very underappreciated aspect of the kind of React ecosystem. Even for people who won't ever build a native application, I think the existence of React Native has been highly influential in React's development and how we think about new features. So even just for the web developers who don't ever use React Native directly, you're getting a lot of benefits from that. That was a big thing. Another one that isn't directly related to React, but is more like in one of the satellite projects is Relay. So GraphQL came out, I want to say that was 2015 when they announced it. And around the same time, Facebook also announced a project called Relay, which is a data framework for React that uses GraphQL to give you declarative data dependencies in your React applications. Nowadays, there are other frameworks, most notably Apollo, which do a very similar thing. But I remember that prior to Relay, or prior to GraphQL and frameworks like Relay and Apollo, the question of how to manage data in your app, in a React app, was always like a big thing. It continues to be a big thing today. But I remember that being a very exciting moment. Is I'm like, aha, these same kind of comments or concepts, like declarative programming and immutability and single directional data flow, they can be applied to things that aren't just the kind of view layer. So I guess that's another kind of milestone I would think of. Another kind of big aspect of the React the history of React is what I think of as like the Flux framework wars. This was around the same time, 2015, and it's from those wars that I kind of emerged originally in the open source scene. So I have a pretty good memory of it. But this was back in the days before a lot of people were using Apollo, or that was even an option, or a lot of people using Relay, or that was even an option. The way that you would manage data from the server, like get data from the server, was you would use this pattern that Facebook kind of developed, but was used by the open source community, that was called Flux. And Facebook released like a Flux library back in 2015, but it was very much like, here's an idea that we think we have. This is how we build applications at Facebook, but we're not so sure about it. So effectively what happened was there's this giant like explosion of every week there was a new Flux framework because everyone wanted to be the guy or girl who created this, the Flux library that would beat out all the other Flux libraries and would be like the way that you build React applications. And so I was one of these developers who came out with, this was like my first open source library. I had a library called Flummox. All of the Flux libraries are based on terrible puns, so mine was no different. But I had a Flux library called Flummox, and then eventually that led to a project called Redux, which everyone is probably a little bit more familiar with nowadays. And that's where I initially met Dan, who is now my teammate and coworker. And Redux kind of ended the Flux framework wars, and now that is kind of Redux and Flux are effectively synonymous. So that's the other kind of big era of the React timeline that I would highlight before we get into React Fiber, which is what I assume what we're going to talk about next.
Yeah. I remember actually, it's funny. I do remember now that you were one of the earlier contributors on Redux, right? I think, didn't you name reducers? Like, I remember reading that a while ago, that you might have come up with the name reducers.
Yeah. So the way that goes, I did Dan and I it was probably like 2 years ago, did like a whole history of Flux episode on, I think it was JavaScript Jabber, where we went through this. I probably am a little fuzzier in the details now, but basically how it went is I had this library called Flummox, and it was originally designed for, I needed to do server-side render with Flux, which at the time was kind of hard because a lot of Flux frameworks use these singletons, which were hard to manage on the server. So I had this library. Dan ended up using it in one of his libraries called React D&D, which is a drag and drop library. I believe people still use that. And so he used my little Flux library inside of his library, and that's kind of how I met Dan on Twitter and on React to Flux, which is like the Slack community for React developers. And then Dan was working on his infamous React Europe talk that he had the idea for, but had no idea how to implement at the time. And it eventually, like, there's a concoction of different influences, but it eventually led to this idea that instead of these stateful, for anyone who doesn't know Flux, I might like elide some of the details, but since we don't want to spend a whole episode on Flux, I'll just summarize it. But effectively, Dan had this idea for, okay, instead of these stateful stores, let's just use these pure functions that map the previous version of a store and some action to a new version of the store. And at the time, he was just calling them stateless stores. So that was like the original idea. He had like a prototype for how this could work with hot reloading, which is what his talk was about. And how it could work with time travel, which is another cool aspect of his talk. And so that kind of fused with some stuff I had kind of thought of with Flummox. And eventually we came up with like this, with what eventually became Redux, which is this incredibly simple pattern that I'm to this day like shocked that it is so popular. And so like there's so many books and stuff written about it because you could fit an entire Redux implementation in like 100 lines. So it's amazing to me how much it's taken off. Like it's a really cool project. Don't get me wrong, but I'm still kind of mind blown anytime I see it mentioned in any context. So I'm like, oh my goodness, it's been 3 years. I can't believe that people are still talking so much about this library that we made. So that's where Redux came from, and I'm really glad. That kind of really changed my career trajectory because that was how I started getting invited to conferences and eventually landed again. I tricked Facebook somehow into hiring me. I don't know how that happened.
Because you're awesome. That's why. And by the way, thank you so much for sharing that. Like, I'm embarrassed about how little I know about web development sometimes. I think like a lot of developers in general, kind of suffer from an imposter syndrome, right? I think the web being as huge as it is, and as change happening every day, people feel the need to like either know everything, and if they don't, they're not good enough. So yeah, thank you for sharing that. That was nice to
hear. I'll share a really short, embarrassing story. Like 2 days ago, I was working on something, and it involved me having to kind of manually manipulate the DOM in a way I hadn't done in a very long time. And I swear I spent 2 hours, like really late at night. I refused to go to sleep till I could figure it out because I had like solved the hard problem that I was working on, and I was spent like 2 hours on what should have been a very simple thing. I was basically trying to like take a list of DOM children and transfer them into a DOM fragment. And I spent 2 hours like frustrated over why something was messing up. And it turns out it was because I was for looping over a list of child nodes when you really shouldn't do that, because what you should really do is use a while loop, because every time you pop something from the child node or delete something from that child nodes list, it's going to change the list. So I spent like 2 hours. It's like kind of a classic web dev, I don't know, thing that people just acquire over time. And I guess I knew that like 2 years ago, but I hadn't done it in so long that I spent like 2 hours on what should have taken me like 2 minutes. So yeah, I am not an expert at all on anything. Don't listen to anything I have to say.
except for this show, and
except for this show.
Yeah, So we're time to get into the meat of the show. React 16, all of the like interesting things around there. It's funny, in kind of like prepping for the show a little bit, I found I think either a gist or a repo that you put up called React Fiber Architecture, and we'll link to it in the show notes. And it was really nice reading over that. I was like, wow. And I think while reading that, you were like, I am not on the React team. I was like, wait a second, is there something did I like not get the memo? Like, I thought Andrew was on the, so you wrote it so long ago that it was, it's funny that you're like following the project so closely. And so what is React 16 all about? Fiber is, something that is an underlying architecture of the rewrite, right? There's some really good changes to the reconciliation algorithm, and being able to, it's kind of more modularized and is able to support both React DOM and React Native, which have their own rendering mechanisms. So I guess if you could kind of summarize like what React 16 is about, what's Fiber, all that good stuff.
Yeah, so there's a few truisms that you hear about software development, and one is that you should never like do full Big Bang rewrites of things, which I think is generally like a pretty good principle. But in the case of React 16, we just didn't listen to that advice. So the reason we decided it was time to rewrite all of React was that, the original React was created in, I think, like 2012 was when the first version of React was written by a guy named Jordan Walk, who still works at Facebook. Really smart guy. And, it hadn't really changed much in I guess it was 5 years or 4 years, I guess at that point, that we had been using it. And it had all these kind of abstractions that might have made sense at the time, but made it really clunky to do any kind of additions to the framework. It made it really hard for open source contributions. The code base was just kind of very inscrutable to someone who was first looking at it, and it also just it made the short of it is it just made development on the React framework itself really clunky and hard to manage. So in addition to that, there are also some new ideas for how we can incorporate new features into React, a lot of them having to do with asynchronous rendering. And it became very clear that it was going to be hard to add those features and these new architectural ideas to the existing React codebase. So those two concepts of async rendering and kind of cleaning up the React codebase kind of came into one project, which we refer to as React Fiber. So React Fiber architecture, again, full ground-up rewrite. The API externally is exactly the same. The reconciliation algorithm, if you use reconciliation, people use to mean different things. What we refer to it is just the algorithm that we use to decide when, like a list of children, if you have two lists of children, one's the old one, one's the new one. Reconciliation is how we decide which things have changed and which ones can be updated versus deleted and remounted. And so that part is actually exactly the same. Like the high-level algorithm is exactly the same. And the idea is all the observable behavior all the behavior you can observe as you use React 16 versus React 15 should be identical. What changed was just all the implementation details about how we actually put it together. So React 16, that came out last fall. It's been very successful. It's a lot smaller. That's one of the nice things about it. But it also has more features that we haven't quite unlocked yet, but they're there, they're hidden in there. And it's going to be a great foundation for the future of React and adding some really amazing new features that we're planning to release this year.
That's awesome. It is anybody that's ever done a full rewrite of anything knows that it's usually a disaster. So props to you guys for it not being a disaster. But yeah, like it's actually been very, very smooth. And as somebody who is a big Angular fan, I do have some experience with Big Bang rewrites that did not go particularly well.
Yes. I think one of the reasons it was successful is, one, we had this idea that like it's unacceptable for us to break any existing React applications.
Yeah.
So we, and it's not just because like a theoretical, like it would be nice to do this type of thing. It's like we would have been fired if we did that probably, because we have 50,000 plus React components at Facebook.
Yeah.
It's absolutely untenable for us to rewrite all of those. So we make use of code mods when we can, but in general, we have this policy of incremental migration, or innovating in place, as we like to say sometimes, which is that you can make changes, but you have to provide an incremental migration path to the new thing, which often means you got to support the old thing for a long time before you finally support for it.
Yeah, and for those of you wondering what code mods are using abstract syntax trees to kind of change code in place, conditionally. And I think Facebook has a pretty cool library called JS Code Shift, which is a wrapper around Recast, which is like the real heavy lifter. It's awesome. Check it out if you have legacy code that you need to update. But so Andrew, how did you guys like? I don't know, how did you guys do it? Like, I don't know how you do a full rewrite without breaking anything. Like, I mean, I like how long did this take? It's kind of mind blowing, actually.
So yeah, it took about a year, I guess. So Sebastian, who's one of my teammates, he is kind of like our technical lead on the React team. He came up with like the initial kind of scaffolding for the project, and like set up the basic architecture of it. That's what my React Fiber architecture talk was based on, as I was basically just stalking Sebastian on GitHub. So it kind of started off in his head, and he made like a prototype of it. I joined in about September of that year. And very shortly after I joined, the decision was made that we were going to, fully commit to this idea of rewriting React for at least the next few months, and assuming it's successful, we'll keep going. There are a bunch of techniques we used that I think made this project possible. My manager, Sophie, wrote a post on the React open source blog. I can't remember the title of it off the top of my head, but I'm sure if you Google for it, you'll find it. But it was last fall, and she details a lot of these techniques we used. One of them was that, we kept basically two implementations in the same code base for, over a year. We had React Fiber and React Stack is what we called the original implementation. And we would run, as we made changes to Fiber, what we would do is we would run the entire test suite against both implementations, one against Stack, one against Fiber. And the Fiber changes, obviously we were going to allow like Fiber wasn't passing all of the tests initially, right? And so for a typical strategy of just like reject the PR if the test fail wasn't going to work. So what we did was we committed into the repo this log effectively of every single test and whether or not they were passing in Fiber. And so the idea was anytime you did a PR in CI, we would run this script to generate this list of tests that were passing and failing. And if there was any change from what was in master in that list, like there were new tests that were passing or new tests are failing, you had to check those in. So when you went to review the PR, the reviewer could very clearly see what changes there were to the test coverage that Fiber had. So this ended up being an incredibly effective strategy for tracking the progress of Fiber over time. We even, our manager at the time, Tom, created a website called isfiberreadyyet.com that had this chart, charting the percentage of unit tests that Fiber was passing. And it was really motivating to see that number go up. And eventually we got all the unit tests passed, or all the unit tests that we had were passing. And then it came about just, unit tests only cover, a small percentage, maybe not small, but only some percentage of the actual behavior of a library. Like there's always going to be stuff that edge cases, things you didn't consider, weird quirks that you didn't think about. that are not captured by your tests. So we went through months of shipping this to first Facebook employees, and then little by little, more and more of our public users to try and flush out any edge cases that we didn't capture in our tests. And then we added, every time we'd find a bug, we'd add a new test to our test suite. So our test suite got even better. And eventually there just were no more bugs to find. And so by the time we released React 16 to the world, I think that's why we were able to have such a stable React 16 release, is we had gone through months and months of testing by the time anyone had ever seen it.
That's awesome. And if anybody actually wants to see something like this, it's kind of in progress currently, because a lot of times these things don't happen that often. If you follow Angular at all, their Ivy renderer, there's an issue in their GitHub. I think if you go to iv.angular.io or something like that, it's that same type of checklist thing. But it's very, very interesting to see that type of stuff while it's in flight. So back to some stuff.
I've got a point while you're thinking. I have a burning question before you ask yours. Is that so I guess a point and a question. So this type of kind of like strangling your legacy application in place is something that like Martin Fowler has talked about a few times, and we'll link to a really good article on this. It's like, you're never really going to get a chance to like stop production for 4 months and rewrite your app, right? But if you do it in a modular way where you're literally strangling pieces of your application bit by bit, like it's pretty cool. So I want to ask, just to confirm, like, was this an in-place? It was an in-place rewrite. So like, were users like using code that were people downloading code that wasn't being run as a consequence of this, or like, how did you guys manage that?
So there were a few months where if you went to facebook.com, you would get 2 versions of React, basically. So not ideal, but we did that so that we could we basically had a feature flag, so some people would see the new version and some people would see the old version. With a sufficiently smart bundler, I guess you could probably avoid double downloading or downloading both of them, but just for infrastructure reasons, that's basically what happened. Is we had some people downloading React Fiber and some people so we had people downloading both, and some people using React Fiber and some people using React Stack. Because the idea was that the goal was that no matter which group you fell into, Stack or Fiber, you should have the exact same experience. There shouldn't be any differences. So that's what we did.
Sorry, was muted. Awesome. So let's start digging into some of the details about React Fiber. So there are two kind of key phrases that I keep seeing when discussing React Fiber. One of them is incremental rendering, and the other one is virtual stack frames. Can you explain a little bit about what those things are and what benefits they give the end user?
Yeah, I think I coined the term virtual stack frame, and I wish I hadn't, because I think we've been talking about Fiber for a while now, and part of the problem, I think, with all it's very useful. I mean, I wrote that thing for myself, that document for myself about almost 2 years ago. Yeah. But one of the problems we were having is when we were communicating this to people, it was a little bit hard to communicate like the actual value of any of these technical things we were talking about, because it was all very theoretical at the time. Like, we had this effectively a prototype of React, but we didn't have any of the cool features that fell out of this new architecture. And we're only now today starting to see the types of features we can build on top of this new architecture. That's what Dan's talk last week was all about, is we've been talking about Fiber for 2 years. Now, these are the actual features you can build on top of it. It's not just an in-place rewrite that has no observable difference and doesn't change your life in any way. There are actual cool features we can build on this architecture. So the virtual stack frame thing is really just an implementation detail. The actual data structure that we use in React is called a fiber. That's why it's called React Fiber. And a fiber is like a scheduling primitive. It allows you to, it's used for coroutines, basically. It allows you to start executing some stack, like when I say stack, I mean like the JS stack or like the actual stack in your in the VM. So you start executing some program, and then mid execution, you want the ability to pause where you are in the stack and resume at some future time in the future. And this is like a form of cooperative multitasking, basically. And that is what the whole virtual stack frame idea is. That's how we achieve, we're calling it time slicing now. But to give you kind of a brief overview of what time slicing is, the whole idea with, or one of the whole big ideas with React Fiber is that we want to make rendering asynchronous. And the reason we want to make rendering asynchronous is that if you have like a lot of CPU intensive work in a web application, whether it's just like very, so in React's case, it'd be like very expensive components to render. If you use React today, all of that rendering is going to be synchronous, which means that until the operation is totally complete, the JS thread is blocked. And because of the way the web works, like when you block the JS thread, it means you're blocking events, you're blocking anything you do inside of Quest animation frame, you're blocking video buffering. There's a whole lot of things that you're blocking when you do synchronous work for long stretches of time in a web app. So what we do with time slicing, because of this new architecture, is we can, instead of doing that in one giant continuous block, we can split it up into chunks and interleave it with other work on the main thread. So that's what incremental rendering means. It means that now if we have a lot of rendering work to do, we don't have to block events, we don't have to block animations, we don't have to block the whole main thread before it's complete. Hopefully that makes sense.
Yeah, one of the things that I always think about when I'm trying to think about this idea of incremental rendering is that it sounds a little bit too magical almost, if that makes sense. And I obviously don't want to get into I don't want to get into the exact, I don't want to go line by line to, it's like, okay, well, how actually did you achieve this? But is it possible in, I guess in a briefer, higher level statement, how did you achieve this?
So like none of the stuff we're doing is that novel. It might be novel for a JavaScript framework perhaps, but it's not that novel if you think of React as basically a VM. That's really how it's architected. The techniques we're using, fibers are not something we invented. The idea of a fiber, I think a lot of it came from OCaml, the way that they do, the way they do concurrency in OCaml. But we didn't really invent any of this stuff. It was like a mix of influences. But again, I don't know if I can give you like an explanation that isn't super in the weeds and not all that interesting unless you see like the actual, I don't know, unless you see an actual demo. But I'll just say that cooperative multitasking is used all over, computer science and engineering. It's the strategy that your operating system uses. It's a strategy that the browser uses. It's a strategy that the OS uses sometimes. It's not a thing that React invented. We're just applying this technique to React. So like I would also recommend that, because this sounds like very technical, I'm going to plug Dan's talk again, where he gives an actual demo of what it looks like in a demo application to have time slicing and have incremental rendering versus today where you don't have it. And it's a lot easier to see the actual impact of what these kind of nitty-gritty architectural details actually have on a real world use case.
So thank you so much for explaining that, by the way, without making my eyes glaze over. Thanks. So I have kind of going back to the platform, right? Web workers are typically leveraged to kind of, offload this type of, computational, anything off of the main thread, right? And so if you leverage web workers or even service workers nowadays, like you're able to kind of say, okay, take advantage of like a quote unquote multi-threading, like, multi-threading in my web app. And so did you guys kind of choose to not use the platform because of, support for like React Native, and like this is like one architecture that would work in like, 3 or 4 different, kinds of rendering environments? Like, I'm just curious, like, why not web workers or service workers?
Yeah, so a few reasons. One I'll say is that there were prototypes of React that were written using web workers. Like we did try that. This was before I was there, but I'm aware of like several attempts to like see like what happens if we just put all rendering work in a web worker. The basic problem, and it is true that like web workers are really good for if you have a lot of expensive computational stuff to do. Putting in a web worker is often can be a good solution for that. In the case of React, though, a lot of the expensive stuff that you're doing needs access to the DOM. And that's stuff that you could maybe do in a web worker, but then there's a cost to passing the information back and forth. Another reason is that like once you put, if you were to just put all of your like reconciliation diffing work into a web worker, you still have the problem of, that helps you free up the main thread for things like events and stuff. But then you still have the problem of what if the thing that you're trying to prevent from blocking isn't like, some event listener or some timeout or some non-React thing? What if the thing that you're trying to avoid blocking is some other React render? So say you have like this really expensive like chart that you're trying to render, and at the same time, like on another part of the app, you're typing into something. So you basically have 2 updates that are happening at the same time. One, you have the really expensive chart that's either animating or re-rendering or reflowing or something, and then you also have someone typing into a text box somewhere else, also rendered by React. The chart is a lot less important than the typing. The typing is way more high priority and needs to happen effectively immediately. And so one of the things that a cooperative concurrency model gives you over just some other type of threading is now we can prioritize those two different updates, not by like putting one thing on a totally separate thread, but having it by switching back and forth between the tasks. So if I put all rendering work onto onto a web worker, I would still have to deal with this problem of how do I prioritize this thing over another thing. Maybe a shorter way of saying this is that if everything is async and everything has low priority, then you still have the same problem if they're all at the same priority level. Like you still need a way to prioritize. There is a possible future where we have like every single update is on a totally separate thread, and that is a model that has that could potentially work. But there are a number of just the short of it is there are a number of things that went into our decision to feel like we need cooperative multitasking as a model. Another thing I'll say is that on React Native. In the native world, threading is a lot more common, where you put work on other threads. But even in our plans for how we will bring the Fiber architecture to React Native, we still have we do use multiple threads in that model, but we still also have this cooperative multitasking idea.
That's super cool. And so you mentioned Dan like dropped some pretty big news and like cool demo at Iceland.js a week ago. And I know a lot of it also was around like what you just said regarding concurrency and all this cool stuff with scheduling events. Can you talk about how the context API fits into this? And also just what is the context API? And I think there's been a few changes, but I guess maybe what's the most recent iteration of the context API?
Could I ask real quick how much time we have left?
Sure. I think we have like 10 minutes left.
Okay, so could I not talk about the context API and talk about the other stuff Dan showed? That's possible?
Sure.
Optimized for.
Sure.
Yeah, because I just realized how much time had gone by, so I apologize.
No worries.
I wanted to talk about kind of the second half of Dan's talk that he gave last week, because this is a thing that I'm really excited about. So Dan showed off 2 demos in his talk last week at JSConf Iceland. And if I don't know if anyone's like listening to this podcast, it might be worth just like pausing right now and going and watching that if you haven't already. But and then coming back, of course. There's kind of what we've been talking about for the last 10 minutes about time slicing and incremental rendering. A lot of that has to do with CPU bound work. So this is work where the user is waiting for something to happen, but it's not waiting on like a network request. It's waiting on just the CPU to do a whole bunch of intensive work. And Fiber is good for that type of stuff. And Dan has a demo that he shows off in his talk that is all about that. There's another kind of work there's another kind of performance problem that people have sometimes, and that is CPU bound work. So this is waiting for a network request to come back, waiting for perhaps you put something in a web worker and you're waiting for that to resolve. It's waiting for like any kind of IO type resource to be ready so that you can continue rendering. And it turns out that the React Fiber architecture is actually really good for that type of problem as well. And what we realized is that once we were able to solve rendering for CPU bound work, a lot of that same architecture made it a lot nicer to render, a lot nicer for solving IO bound work as well. So the kind of one. There's a few ways to tackle this new feature. And again, it's very hard to describe in the abstract, so I really recommend you go and watch that video. But let me just like go about it this way. If I can ask you all a question, what is like one of the biggest ways that you can improve the performance of a web app nowadays?
Lazy loading?
Yeah, lazy loading. That's exactly what I hoped you would say. Lazy loading, code splitting is like a form of this. So like rather than load all of your the code for your components up front, you just load them as they're needed. You can also lazy load data, of course, like don't fetch the data until you actually like hover over something or until you actually navigate to a new route. So a follow-up question, since like things like Webpack and these like new bundlers make like dynamic code splitting fairly easy, what's the reason why people don't just do that for everything? Why don't people lazy load nowadays?
They either don't know how or don't know they're supposed to.
Yeah, or their routing is messed up. Like, I think that people just don't have a good routing routing architecture. There's all kinds of things, and even with that, I think sometimes the like people have nested components. Like, so in one route, like they might have like 10 child components that are really like all large and nested. So I'd say a bit of both.
Yeah, like the thing you were just saying, Amal, I think is a really good point. This idea of like if you code split and lazy load like too granularly, if that's a word, it can create these waterfalls. It's not just a this waterfall idea is not just a performance consideration. It's also like a user experience consideration, because how many times have you like opened up a website and like loaded the page and you just see like 15 spinners flicker on and off. You see like these empty spaces where things haven't filled in yet, and then like a split second later it fills in with the actual thing. Next time you use like I don't want to throw any particular website under the bus, but let's just say next time you use Facebook.com or next time you use Twitter, like just count how many like spinners that you see like flash as you load the page or as you like click on a tweet or something like that. It's all over the place because the way that frameworks like React and other frameworks are the way that they're written nowadays is that if you lazy load something and you go to render a component and that thing hasn't loaded yet, you really only have one option, which is to render something else instead. You have to either render the thing because it's loaded already, or you render some spinner or some empty space or some placeholder or some placeholder effect until the thing comes back. And I think people kind of take this for granted that that's like an inherent problem of web development, but it doesn't really have to be. So what we're calling it React Suspense. Is this new feature of React. What React Suspense does in like a very, very brief nutshell is it gives you another option. Rather than having to wait for all of your data to load and then start rendering it, rather than having to wait for the data to come back and then start rendering, or having to render a placeholder immediately and then have this weird like flickering effect. What you can do with React Suspense is tell React, hey, I don't have everything I need to render yet, so please just don't render anything until this promise resolves, and then you can continue. So we call that like suspending the rendering process. And it sounds like that's not that fancy, like, oh, you're just, blocking React from rendering. Why is that so cool? But what it allows you to do is build web applications and render components without having to know whether or not they're synchronous or asynchronous, and also without affecting the user experience in any way. So you don't see crazy flickering of images. You don't see placeholder views that pop in and then pop right back out once the data loads, and it creates a much nicer user experience. And as a consequence, because the user experience woes are mitigated, it also makes it a lot easier to lazy load more and more things, which in fact like makes the performance of your apps a lot better. So this is very abstract descriptions. One thing we realized is it's almost impossible to sell this stuff in an abstract description or on a podcast, unfortunately. But we're at a place now where we have like working prototypes of these features. And so that's what Dan was able to show off at JSConf last week. So I really recommend that y'all go watch that video, because it's pretty exciting. I think it's going to have it's going to really change the way that React applications are architected.
Yeah, I that sounds like a big deal to me, and thank you for so nicely describing it. Like that, like jank and all of the motion around the in between states is one of the most annoying things about creating a web app. And so if you're able to kind of deterministically provide the same behavior for components, whether they're sync or async, like that's a huge thing, without having to like have a bunch of extra bloat around skeleton content and things like that. So that's really awesome. And so where can people learn more about that besides the talk, which we're going to link to, and the React blog post? Is there a project, or is this is all?
Yeah. So, the talk is probably the best place to start. We will have a blog post at some point. This is kind of like my full time. This is like all my attention is focused on this right now. So we're very interested in shipping this. It might take a while for it actually to get into a public release, because we want to do what we always do, which is actually try this out on some internal projects and on Facebook.com to prove that it actually works and we aren't just theorizing about this stuff. But I am feeling more and more confident every day that this is going to be very helpful for React developers and for React applications. It was based on ideas that our fearless leader Sebastian had, over a year ago about how we can. I think originally the germ of the idea came from server-side rendering, because this problem also exists on the server, where you need to server render this giant tree of components, but you don't necessarily have the data for all of them yet. So I'm very excited about this project. If you want to, you can watch Dan's talk. You can follow our Twitter account at React.js. And I'm sure that we will be posting some updates on the blog soon as well. And there's like an open PR that you can look at. I don't know how interesting it is, but people have been posting questions there. So if you absolutely want to like look at some of the nitty gritty technical details, there's an open PR in GitHub that you can look at too.
That's great. So we are almost out of time. We have time for 2 more questions. Hopefully you'll keep it. We're going to try to keep it quick and short. But okay. And then this is a really hard question, and I have to ask this. It's my favorite question to ask, like framework authors on the client side. So like React has kind of pushed the web like forward in so many ways, like the web developer experience, right? JSX, you name it, like standardizing on like lifecycle events on the UI, just, being able to interoperably like use React alongside Backbone or Angular or anything. It's just awesome, right? But like, so are a bunch of the kind of innovations and ideas that have come out of working on various React projects, are they feeding back into the platform? Like, are there new language features or web standards that the React team is working on, with in W3C or TC39 that are like going to be a thing on the platform?
Yes, that's a really good question. We do have like fairly regular contact with, web platform folks. Sometimes, unfortunately, there's like this perception that we're at odds. I hope that I don't think that's true. I don't think that we're at odds. It is true that like some of the web component stuff that's been happening recently doesn't like totally align with our thoughts on how like scheduling should work. It's not that we agree on everything, but I don't think there's any reason why like React and the web platform should be in conflict at all. So in terms of like specific APIs, we have like made suggestions for things that we think could be better. A small example is, the time slicing feature that we use relies very heavily on request idle callback, which is, if you're not aware of what that is, oh yeah, so sorry. Amal just said in chat, object spread. Yeah, that's one. I guess that's more of like a JavaScript platform, JavaScript's platform feature. But yeah, object spread is something that came from JSX. It was like a convenience that we were using to make JSX a little nicer, and now you can use it in any JavaScript. So that's pretty nice. But yeah, request out a callback. We had like a suggestion that it'd be nice if we had a little bit more control over how callbacks that we schedule with request out a callback are prioritized. We have some. Sebastian had this thought that maybe we wouldn't have to use request to idle callback at all if we had a little bit more control over when events are dispatched. So if we were able to just spin the event loop and dispatch events synchronously whenever we wanted, maybe we wouldn't have to yield to the main thread quite as often, and we could have, theoretically, we could have avoided all of this, these virtual stack firms, quote unquote, in the first place. So we definitely provide feedback and try and give back whenever we possibly can.
That's cool. I heard the virtual DOM might be something as well that like might be like the reconciliation around the diffing with DOM nodes, like that might be something that we see in a proposal. Was that just like a rumor?
I'm not aware of any, like, I've heard that idea thrown around a bit. I'm not really aware of any like proposals that are that are anything more than just like a glimmer in someone's eye. But maybe yeah, I don't know. Maybe that could happen.
I think at the moment that's all it is. I actually remember speaking to Rob Dotson about it, and he had talked with some browser developers, and they seem to be pretty. It seems like it would not be an easy thing to do, especially in the backwards compatible way that the web tends to be. Would be cool, though.
Yeah, I'm also just kind of skeptical of how much it would help. It would maybe help in the sense that you don't have to download as much code, I suppose, but like in your frameworks. But like we typically, the things we ask for tend to be like lower level things that we can build on top of, because just the nature of any standards process, by the time you add something into a standards, by the time some standards body like accepts something, like the community is probably like innovated past it like 3 years ago. So I'm usually more excited about like the lower level things that have like a greater chance of being useful even after the next big thing comes out. Because who knows, like tomorrow someone could come out with this crazy innovation that totally makes React obsolete, and that would be awesome. So I don't think we should go and start baking React into the framework, into the platform forever.
Yeah, the extensible web, like just exposing like lower level primitives, like that seems like the way to go, because ultimately like the web standards community is always going to be following the kind of the trail of web developers, and it's almost like a tortoise and a hare, like so I think I'm more for like exposing more primitives to developers and then just letting them do whatever they want, so but anyways, with that said, looks like we are out of time. I was really hoping for one last question, but it's fine. We're gonna just have to have you guys back. And like again and again, and I'd love to even do a whole show on like Create React App with Dan. I mean, there's so much to talk about, so you're just gonna have to come back on the show in a few months. I really thank you so much. This has been, it's like been a brain dump of info. So
yeah, it's been fantastic.
Yeah, thank you so much for having me.
Yeah, it's been fantastic. And like Amal said, so sometimes there's just not enough time to cover all the stuff that we really want to. So we'll just, I mean, the worst thing is that you just have to come back and talk to us more. That is it.
Yeah, I can be kind of a chatterbox and go off the rails sometimes too. So apologize if I was a little too long-winded in some of my answers.
Love it.
Yeah, no, you're really passionate about what you do, and you're like it shows. So I forgot, like I had one corny joke to make. You guys, it'll take 30 seconds. You guys ready?
Okay.
So you remember how you asked a question earlier about web performance? What's the fastest way? And Danny beat me to responding, but my response was going to be, I only code with while true loops. Didn't only blocking code for me.
Nice.
Anyway. All right. Well, so Danny, you want to take us out?
Sure. So again, Andrew, thank you very much. This has been a lot of really good insight into React, into a little bit of the history, how we got to now, some of the really cool stuff you're doing, a little bit of the process of how stuff gets out. Are there any last things that you wanted to mention before we sign off?
No, I'm very excited for what we're working on with React, and so I'm excited for everyone else to be able to use it as well. I'm very excited to ship. Let's say that.
Fantastic. So if anybody wanted to get in touch with you or anybody else on the React team, what are some of the best places to go? Is it Twitter, GitHub? What is it?
Yeah, GitHub, opening an issue on GitHub if it's an issue you have with React itself is always a good way to go. A lot of us are very active on Twitter, so my handle is ACDLight on Twitter. There's a React.js account on Twitter. Dan tweets a lot. Sebastian, Dominic, Flarney, Brian, we're all Sophie. We're all very active, so it's pretty easy to get in touch with us if you need to. Awesome.
Well, Amal, thanks for hanging out with me, and so that we could talk to Andrew all about this awesome React stuff. This has been episode 156 of the Web Platform Podcast, React 16, Fiber, and beyond.